So, hello, dear students. I welcome you to the another topic that we will be covering in the novel drug delivery systems. So, as our discussion is going on to understand the various theories of the mucoadhesive drug delivery system, in today's session, our objectives are to discuss the diffusion theory, the fracture theory, the advantage of the mucoadhesive drug delivery systems, and if there are some limitations or disadvantage with the mucoadhesive drug delivery system. So we shall be covering these two leftover theories, means three theories we have covered in the previous session, and now we are left with only two theories, so we will be covering them in this session. These theories and the advantage and disadvantage of the mucoadhesive drug delivery system, we will be covering in this session. As of now, we have understood that there are various theories which actually governs or which predicts us how effective a mucoadhesive system would be, and what are the possible causes when the mucoadhesive polymer is getting attached with the mucous membrane. So, what things we need to understand? What are the possible outcomes, means whether the permanent mucoadhesion is required or reversible type of mucoadhesion is required. So we have understood them in detail with the previous theories. So coming towards the discussion and extending the discussion further with the diffusion theory. So, as the name says, it is actually working, or it depicts, or we can say it describes the phenomena in which the polymeric chains are actually interpenetrating with the mucin chains. So, actually, the means stronger the interpenetration between the polymer and the mucin chain, the better will be the mucoadhesion. So you can see the interpenetration of both polymer and mucin chains to a sufficient depth actually creates a semi-permanent adhesive bond. So it is a semi-permanent adhesive bond, and this actually is believed that the adhesive force increases with the degree of this interpenetration between the polymer that we are using for gaining the mucoadhesion and between the mucin chains. So higher the interpenetration between the polymeric chains and the mucin chain, better will be the mucoadhesion. So this theory describes this process. So let us understand in detail this diffusion theory. So you can see we are having polymeric chains on the dosage form. So this is our dosage form, means depicted over here in purple color, and these green color means thread like structure are the polymeric chains, and this red like structure are the mucin chains. So you can see in the second state, the interdiffusion process actually occurs, and the green color polymeric chains are getting mixed up with the mucin chains, sorry. So better the interaction between these two chains, that is the polymeric chains and the mucin chain, harder or stronger will be the mucoadhesion. So you can see the penetration rate, means how effectively this polymeric and the mucin chains are penetrating or intermixing with each other. It actually depends on the diffusion coefficient. So higher the diffusion coefficient, better will be the mucoadhesion. Similarly, the flexibility in these polymeric chains. So if they are not flexible and they are stringent, or we can say very much hard in their structure, so that will not lead to effective intermixing or interpenetrating with the mucin chain. Similarly, the nature of mucoadhesive chain is another important aspect, and the mobility as well as the contact time. So, whether they are diffusing but they are not getting sufficient contact time with the mucin chain to interact with, so they will not be getting permanently, means semi permanently adhere to this polymer this mucin structure. Now, how we can measure the effectiveness or the depth of interpenetration? So, actually, the effective bioadhesive bond lies when the interpenetration is in between this range, that is 0.2 to 0.5 micrometer. So, if this is the case, it will be providing us better or efficient bioadhesive system. Are we clear? I think so. The diffusion theory can be explained through this equation also, and we can define the interpenetration depth of polymer and the mucin chains. So we can use this equation to estimate the how much actually betterly this interpenetration is happening. So you can see over here, T is the contact time, dB is the diffusion coefficient of the mucoadhesive material in the mucus. So better the diffusion coefficient, better will be the interpenetration between the polymer and the mucin chains. So now the next theory and the last theory which we will be covering is the fracture theory. So you can see the name says fracture. So it is actually depicting us ki when a polymeric system is applied over the mucin layer. So what force is actually required to separate them out? Means let us suppose ki the polymeric system has been uh, means adhered, it has been adhered onto the mucin layer. So how much force we actually require to just remove this mucoadhesion? So higher the force involved to just create this fracture, you can see over here in the mucin layer as well as in the our device, so better will be the mucoadhesion. So you can see it analyze the force required to separate two surfaces after adhesion has been established. So fracture in hydrated layer of device, this is represented over here. Fracture at the interface, so what is the interface between the mucin layer and the hydrated device? And you can see over here, so how we can measure the effectiveness? So we can measure by measuring the maximum tensile strength during detachment, and it can be expressed by this equation. So G is equal to E epsilon over L to the whole power 1 by 2. So where E is actually the Young's modulus of elasticity, where epsilon is representing the fracture energy, L represent the critical crack length when two surfaces are separated, and G is the fracture strength actually which we are calculating. Now one thing important to remember over here is that during this fracture theory, and when we are measuring the force required to actually separate them out, the polymeric system and the mucin structure, so we are not taking into account the interpenetration or diffusion of polymeric chains. So if it is so, so this theory will not be applicable in that case. Now we are coming towards the advantages. So you might be understanding the application of the mucoadhesive drug delivery system. So actually the application is only derived from the advantages. So as we are targeting some mucoadhesive polymers, we are designing some mucoadhesive polymers, and they are meant to be adsorbed onto the mucosa of the body. In different mucosa we have undergone. So we also learned about this, that when we are trying to get the drug absorbed from this mucoadhesive system, so actually we are delivering the drug directly into the systemic circulation. So we are bypassing the first pass metabolism if some drugs are getting through it. And another important advantage is the ease of administration by these drugs. And as you might be knowing that we can also administer these type of drug to the unconscious patient who cannot administer the medicament by themselves. And obviously as we are directly targeting the oral mucosa, which is highly perfused and means frequently supplied by the blood supply, so it also offers faster onset of action. Similarly, when all these means criteria are met, and these are the advantages, so we can say it will actually improve the patient compliance as well. And as measure means some drugs are acid sensitive, or they are sensitive towards the enzymatic or alkaline environment in the intestine, so they can also be prevented from getting degraded before reaching to the target site, because actually we are bypassing these routes. And it also offers greater permeability than a skin, means if you are targeting the transdermal route or you are developing the transdermal route, so this can also means offer us advantage over the transdermal drug delivery, because here the skin is the major barrier, so we have to bypass or overcome this barrier to deliver the drug through this route, that is the transdermal drug delivery. But here, as it is highly permeated, so we can easily deliver our drug through this route. And obviously, as we are bypassing the first pass effect, minimizing the elimination of the drug, so we should be requiring lesser dose for the therapeutic action. So as this route is having multiple advantages, but no delivery system is means devoid of some limitations or disadvantage. So you can see we can only deliver those drugs which are can or which can be delivered through means from sorry for the miscommunication, so which can only be delivered through a small dose. Similarly, any drug which have any bitter or unpleasant taste or obnoxious odor, so it will irritate the mucosa of the oral cavity. So we cannot advocate the formulation of these drugs which have bitter or unpleasant taste or have some obnoxious odor. So this is the limitation of mucoadhesive drug delivery system. And as we use oral cavity for our eating and drinking purpose, so this may hinder the action or sustained drug action or mucoadhesion process, because during the mastication process or drinking, these dosage form may lose their mucoadhesion properties. So we should be keeping in mind this concept as well. And drugs which are unstable at the buccal environment, so these are specific drugs, we should be avoiding them to be formulated as mucoadhesive drug delivery systems. And drugs which show passive diffusion can only administered by buccal route. So this is again a very important limitation, or we can see we can means have key the understanding that only those drugs which are easily absorbed by passive diffusion process are good candidate for the mucoadhesive drug delivery system. And permeability of buccal mucosa is low as compared to sublingual route. So, as compared to the buccal mucosa, the preferred choice for drug delivery would be sublingual route, because it is highly permeated with the blood capillaries. So, these are some limitations. So, I thank you all.